We cannot solve our problems with the same thinking we used when we created them.
Most people think Albert Einstein won his Nobel Prize for E equals mc squared, or the general theory of relativity. But they are wrong. In 1921, the Nobel Committee honored Einstein for a different breakthrough: his discovery of the law of the photoelectric effect. This work didn't just explain a laboratory phenomenon, it birthed the entire field of quantum mechanics. By 1905, the scientific world was convinced that light was a continuous wave, perfectly described by Maxwell's equations. But there was a massive problem. When you shine light on a metal plate, it sometimes knocks electrons loose. According to wave theory, if you use a brighter light, those electrons should come flying out with more energy. But they didn't. Instead, the energy of the electrons depended only on the color, the frequency of the light. Einstein proposed a heuristic, a mental shortcut that was considered radical at the time. He suggested that light isn't a continuous wave at all, but is composed of discrete quanta of energy. Today, we call these photons. He used a simple but profound equation: E equals h nu, E equals h nu, where E is the energy of a light quantum, h is Planck's constant, and the Greek letter nu represents the frequency. This meant light was quantized, delivered in packets, not a steady, unbreakable stream. Einstein explained the effect using the law of conservation of energy. He wrote that the maximum kinetic energy of an ejected electron is equal to h nu minus phi. In this equation, phi is the work function, the minimum energy needed to pull an electron out of a specific metal. Think of it like this. If the incoming photon's energy is less than the work function, nothing happens. It doesn't matter how bright or intense the light is. If the individual photons don't have enough punch, the electrons stay put. This paper proved that light has a dual nature. It acts as a wave in motion, but as a particle when interacting with matter. This heuristic point of view was the first step toward the modern quantum world. It proved that energy is not continuous, but grainy. While relativity redefined the universe on a grand scale, the photoelectric effect redefined the universe at its tiniest level. It remains the foundation of solar panels, digital cameras, and the very sensors in your smartphone. Thanks for listening to Calculus Craze. Stay curious and keep calculating.